Welcome to our review on the Group 1 elements. So the first thing we need to remember then is where we actually find Group 1 on the periodic table. So if you look at your periodic tables, what you'll find is the far left hand column is Group 1. Okay, and remember, you get a copy of the periodic table on your exam paper on the back page, so you don't have to memorize any of these names at all. You just need to know where to find it. Now, Group 1 are also referred to as the alkali metals, and we're going to find out why that is as we go through this little review PowerPoint. So when we look at the periodic table, what we'll find is that there are 6 different elements in Group 1. So you've got lithium, sodium, potassium, rubidium, cesium and francium. And you can see all of those in that first column on the periodic table. Now, what we find is that the lithium, sodium and potassium that you saw in class are all very reactive with air and water. So when you actually saw them in your lesson, you'd have noticed that they're stored in those jars in oil. Now, the whole purpose behind storing them in oil is to stop them reacting with the moisture and the oxygen that we find in the air that surrounds us. So if we put them in oil, obviously it prevents those coming into contact with the metals and therefore prevents those reactions. So they do like that question on your exam paper, asking you how they're stored and why. So they're stored in oil in order to prevent them reacting with the moisture in the air around them. So in class you actually watch the reaction of lithium, sodium and potassium with water. So if you remember, lithium, when we put it in there, it produced bubbles and it disappeared quite slowly. So it was quite a slow reaction there. When we added the sodium to the water, it disappeared quicker than our lithium, and as soon as it touched the surface, it didn't stay as a solid, it actually melted to a silvery ball that darted around on the surface really quickly as that gas was made. Finally, our potassium disappeared the quickest of them all, and as soon as it touched the surface, it melted to that silvery ball, and then also burst into flame and burnt with that lilac flame as it zipped around on the surface. So when we actually look at the reaction that's taking place as we add that alkali metal to the water, then what we've got at the top there is our general word equation. So we've got the metal plus water makes metal hydroxide plus hydrogen. So the only thing that's actually going to change when we're writing this for a particular reaction is the name of the metal. So I've given you the example there of our lithium. So lithium plus water makes lithium hydroxide plus hydrogen. So literally the only thing we've got to do is write the name of the metal that's reacting at the start and before the word hydroxide to get it right every time. Now, we noticed that when we put them into the water, they all react in a very similar way. And the reason that they react in this similar way is because of their electronic structure. So all of our Group 1 metals have one electron in their outer shell. So what we actually find is, as they're reacting, they will lose that electron from their outer shell to make a single positive ion. So what we can see at the bottom there then is the symbol equation for the reaction we've just talked about. So M just stands for our metal, and then obviously the other chemical symbols are appropriate to the relevant chemicals. So when we look at it, we're going to have 2 of our metal plus 2 water, H2O, and that's going to make 2 of our metal hydroxide plus hydrogen gas, which is H2. So anytime that you're asked to write one of those balanced symbol equations for the alkali metals and water, it will be exactly the same because they all react in the same way. They've all got one electron in their outer shell, so they're all going to end up with 2 of the alkali metal reacting with 2 molecules of water to make 2 molecules of our metal hydroxide and 1 molecule of hydrogen gas. Another one of those common questions they like to ask you is how you'd actually test for a particular gas. And obviously in this experiment we generate hydrogen. So if you think back to lower down the school, you should remember that to test for hydrogen gas, what we do is take a lit splint and then put it into the tube with our gas, and if we get that squeaky pop sound, we've made hydrogen. So that can be a 2-mark question there. 1 mark for saying you place a lit splint in the tube, 2nd mark for describing the squeaky pop sound we generate.